All right, welcome back, everybody. Warm-up is here on the board. Go ahead and do that if you need to, if you're following along at home. But my in-class students, I know, have all finished their homework assignments. So there's Trent, you want to say hi in the video?
Oh, no.
Trent, you have a good day. Hey, Trent, will you do your homework today?
Oh, yeah, I got it.
You got it? Are you sure?
Yeah. It's on video.
Good boy. It's on, yeah.
It's
He's
on
bound.
video.
It's on video. It's
Do
been
it
recorded.
now.
I don't know. Yeah, sure. All right. Okay, so let's take a look here. Let's remind ourselves about horizontal and vertical lines. Okay. So for horizontal lines, or sorry, for y equals lines, Ella, are y equals lines horizontal or vertical? Horizontal, good. The y equals lines are the horizontal lines. Remember, y equals is horizontal, x equals is vertical, and I kind of just gave that one away. So if it's y equals 2, that means it's just a horizontal line at 2. Pretty simple, right? You just have to learn which one. Like, somebody was like, well, I don't get it. I don't know what to tell you. You just got to memorize that y equals is horizontal and x equals is vertical. There's nothing to get. Just learn it. Number 2 here. So x equals -3. So easy question. Preston, is it horizontal or vertical? Vertical at -3. That means I'm going to go to -3 and write my vertical line at -3. So -3 right here, vertical line. Ooh, hopefully not as curvy. There it is. Okay. So use the intercepts to graph the equation. Use the intercepts to graph the equation. We talked yesterday about standard form. Remember standard form being that ax plus by equals c. Ax, by, and c. A number times x plus or minus a number times y is equal to a constant on the end. So x minus 3y is equal to -9. So if I wanted to find the y-intercept, Henry, if I'm looking for the y-intercept, where do I plug in the 0? Good, for the x. So I'm going to say, so this is 0 minus 3y is equal to -9. This is going to give me the coordinate 0, comma, the number, right? 0 for the x, number for the y. So this -3y is equal to -9. Henry, how do I finish this off? How do I solve it? Not multiply. I'm already multiplying. How do I solve it? What's the opposite of multiplication? There it is. It's what glasses help with. Division. Get it? Glasses help with.
Oh! You just got that?
It's so obvious that we got away.
Hey, this is the palace here.
That's
This is
way cold.
I call it the country club.
I want to go to one
Almost all of the teachers at Lake have
Okay, let's get back to math here. So we have x minus 3y is equal to -9. If I wanted to find the x-intercept now, Gio, what would I do to find my x-intercept?
You would use the first.
If I'm finding the x-intercept, where does the 0 go, Gio?
In the middle of the graph.
I'm talking about in my equation, Gio. If I have x minus 3y and I wanted to find the x-intercept, the 0 goes in for the y. That's what I was asking you. You say it goes in for the y. So x minus 3 times 0 is equal to -9. Now, Gio, what happens with my -3 times 0?
You're going to cancel that out.
It cancels out, leaving me with x equals -9. So what's my coordinate, Gio?
-9.
Comma.
X, or 0.
Yeah. Why am I pushing you guys to do that? Because I need to stress to you guys that that is a coordinate. Can I show you, as I was walking around, and this, I'm remembering this from years past, you want to see what I get a lot? Everybody look up at the screen right now. This is what happens a lot. People do that. I mean, I asked you to graph a line, and you gave me a point. That's the first problem. Second problem is that those should be two separate coordinates. I see where you're getting the numbers. Actually, it should have been, no, that's the right way around. Negative 9 comma 3, I see where you're getting those numbers. But it's not negative 9 comma 3. It's negative 9 comma 0 and 0 comma 3. That point is not even on the line. The correct point should be 0 comma 3, negative 9 comma 0, connecting our line between them. Okay? Yeah.
Would you take blank off the coordinates?
I will give you blanks for the coordinates. And it'll look like what it looked like on the quiz last week with the parentheses. Again, should you just be connecting your dots? No. Extending through the dots, arrows in the end. Okay. I hope there's no questions from 1 through 4. I mean, those should be pretty simple. Again, you just got to learn which one's horizontal, which one's vertical, and then graph it as such. But I'd love to go over at least one from questions 5 to 17. So you pick. Or, okay, go ahead. Yeah.
11.
11. So let's take a look at 11. Send to a new page. All right, so I want to find the intercepts and graph. Find the intercepts and graph. Well, the first thing that I want to do is find the x-intercept. So let me ask Noah, if I'm finding the x-intercept, which one goes, where does 0 go? For the y, good. So I'm going to say negative 12x plus 3 times 0 is equal to 24. What happens with my 3 times 0, Noah? Cancels out. Leaving me with a negative 12x is equal to 24. Now, I had somebody say to me last period, okay. I see a pattern. If it's in standard form, can I just go straight to the negative 12x is equal to 24? Like, can I just think about covering up the 3y and just solving that equation? Of course. That's the beauty of standard form. That's why standard form is so useful when solving for intercepts. It's because you could just kind of ignore the, put a, cross out 3y and just solve that equation. Yeah, totally fine. And then what you do next time is just ignore the other piece and solve that equation. Yes, that's why standard form is nice. So let's keep going with this one. We divide by negative 12 to both sides, so x is negative 2. Again, the coordinate being negative 2 comma 0. That's the coordinate. Okay, now, if I want to find my y-intercept, Nathan, where does the 0 go now?
In the x.
In the x. So negative 12 times 0 plus 3y is equal to 24. And again, you can cut straight to just 3y is equal to 24 if you'd really like to. You're going to see me from here on out just doing that. I don't really need to plug in the 0, especially if it's in the standard form. So y is 8. Again, the coordinate 0 comma 8. Now let's graph this. I need a full 10 by 10. Nope. Try it now. One more time. Like the announcements this morning. Are they going to work? There it goes. Okay, we've got negative 2 comma 0 and then 0 comma 8. There we go. Ooh. Do that.
What?
Questions on that? Questions on that? Are there any other questions on any of the homework? Yes. Number 7. Is this the one with the weird fractions? Yeah, that's kind of a weird one. I'm glad we're going to go over this one. Come on. Come back to me. Okay. the same process applies, right? I plug in 0 for x and solve for y, plug in 0 for y, solve for x. However, let me ask you this. Everybody look up at the board. Is that standard form?
No.
No, that is not standard form. So can I cut straight to the, like, just little equations? No. Okay, requires a little bit more work. Still not too bad. So we're going to say 3x is equal to 6 times 0 plus 2. Still going to cancel. So 3x is equal to 2. Now, I divide by 3. Get x alone. So x is 2/3. If you wanted to give it to me as a decimal, I think I wrote it as a decimal on the key, 0.67. That's fine too. I'm going to keep it as this fraction, 2/3 comma 0. Same thing for my y-intercept. I plug in 0 for x now. 3 times 0 is equal to 6y plus 2. Well, again, 3 times 0 is going to cancel to be 0. And then I've got this equation to solve. Okay, well, I subtract the 2 over to the left side. Then I divide by 6. Negative 1/3 is equal to y. And again, 2 over 6, I just simplified that. 2 over 6 to 1 over 3. Okay, well, that's 0 comma negative 1/3. Now, my 10 by 10 graph is not going to help me here, so I'm just going to make a graph. So I'll make this 1, 2, 1, 2, 1, 2, 1, 2. All right, my x-intercept is 2/3. Somewhere around right there. My y-intercept is negative 1/3. Somewhere around right there. And there's my line. Questions about that? Good there?
Yeah.
Anything else on the homework that we'd like to talk through? Oh, forgot to do the warm. Did I do the warm?
No.
I did. I did this the other way around today, didn't I?
Yeah.
I should do homework first, then warm up. No, that's okay. Let's get to our notes for today. Now, notes. We got 2 problems to do today. 2 problems.
Yeah.
You may be thinking, oh, sweet, it's going to take like 5 minutes.
Nope.
They're gonna be extremely long problems.
Yeah, 2 word problems to do.
I don't know.
One on the front, one on the back.
Take your break.
Here we go. So again, so just doodle on my graph paper.
You only get 2. I have the paper, that's why I said. You good,
Let's
good?
get these tests.
Good.
And then we'll see how we go.
You good?
I'm ready for this.
You good? That's okay. I keep yawning and my eyes are watering and it's gonna ruin my eyes.
All right, so I kept saying, oh, I never checked your phone. You're submitting. So I have been saying in this lesson that standard form is, I think I kind of said this yesterday. It's kind of like the one that's the form that's forgotten about it in terms of the linear equations. Everybody knows slope-intercept form. It's like the celebrity of the linear equations. Like everybody knows y is equal to mx plus b. We'll get to that in section 3.6. We'll talk about slope. We'll talk about y-intercepts, slope-intercept form. That whole deal. We'll spend 3 days on section 3.6. We'll even talk about another term, another type of equation called point-slope form, which you actually talk about in the other class, the one that starts with a G. I won't name it. Everybody kind of cringes when they hear geometry. I just said it. It's like Voldemort. You don't want to say it. But point-slope form is one that's used a little bit more in geometry. We'll talk about what that means and what that is. But standard form is not one that's used quite often. But here's where it's useful, when graphing intercepts, right? And a lot of times, word problems are presented to you in standard form. Let me show you what I mean. Okay, we are planning an awards banquet. We need to rent tables, and 180 people are coming. Okay, we have 180 people coming to this thing. I have 2 different size tables to choose from. Small tables and big tables. The small tables seat 6, the big tables seat 10. Now, I didn't need to give you this equation, but I gave it to you here. 6x plus 10y is equal to 180. By the end of this chapter, I'm going to be expecting you guys to create those equations. Think about it. If x is the small tables, y is the large tables, if I'm totaling 180 people, we'll apply the people to the numbers of tables. 6 times x, x being the number of small tables I have, 6 times x plus 10, the number of people in a large table times the amount of tables that I have, 10 times y is equal to my total 180. Now, let's graph this. Do you guys see how the equation is given to us?
Mm-hmm.
Standard form. 6x plus 10y is equal to 180. So let's do exactly what we've been doing yesterday. Let's graph using intercepts, but now we're going to follow the next direction and interpret those intercepts. Okay, so if I want to find my y-intercept, or my x-intercept first, we say 6x plus 10 times y, 10 times 0, is equal to 180. Or just think about, okay, the 10 times 0 is going to go away, leaving 6x is equal to 180. I divide by 6, x is 30. That's no different from what we've been doing yesterday and in the homework. So what is the intercept? The intercept is 30, 0. There's my x-intercept. Let's do the same thing for my y-intercept. My y-intercept is 6 times 0 plus 10y is equal to 180, or just 10y is 180. Divide by 10, y is 18. So my intercept is 0, 18. What does that mean? What do those points mean? Let's first examine 30, 0. What do you think 30, 0 means?
There are 30 small tables.
Be more specific.
Um,
What's the y value?
The y value is
I'm talking about in this coordinate. 30 small tables and how many large tables do I need if I have 30 small tables?
0.
There it is. That's the interpretation. 30 small tables and no large tables will get us 180 people. Okay, that's the interpretation. We need, and there's plenty of space there to write this out for you guys. We need 30 small tables with no large tables, or 0 large tables, for 180 people. The intercept, interpretation of the intercept is always, if I have 0 of one, that means I got to have this many of the other. Okay? So, likewise here, obviously I'm going to need less large tables, right? I need 30 small tables because I need 180 people. I only need 18 large tables, right? 18 large tables and how many small tables? 0. We need 18 large tables with no small tables. For 180 people. You need to reference, and again, just like I've been saying all along, I've been giving you tips on how to interpret things. Here's my tip on this. You need to reference having none of the other type, whatever it may be. You need to reference having none of the other thing, and then reference the total. Like, for example, 30, 0. We need 30 small tables with no large tables for 180 people. 0, 18. We need 18 large tables with no small tables if we need 180 people. Yes?
This is the same thing, but like, why do we need 2 equations for one? Like, when it's asking how many tables we need, why are we saying we need 30 small tables and no large tables, and then saying that they only need large tables and no small tables?
Because we're giving all the options. We're giving all the options. This is not saying we're having 2 banquets. No, this is saying if I wanted to only have large tables, I need 18 of them. If I wanted only small tables, I need 30 of them. Because later on in the next question, it asks, give me some possible solutions. We're going to give some points in the middle. We're going to see like, okay, we could have this many, then this many, and this many, and this many. Yeah.
So for another one, like if let's say they wanted small and large, what would we? I don't think we would.
Pause on that because we're going to talk about that right here.
Oh.
Pause on that. Let's graph it real quick. What's my are there any labels on my axes?
No.
We should label them. What's my x-axis label?
Small tables.
Small tables. And my y is large tables. All right, so small tables is 30. Going up by 2s here. Large table is 18. Going up by 2s on that as well. And I'm going to be very particular how I graph this. I would, when you're doing word problems, use a straight edge. And you'll see why here in a second. I'm going to go from right here, snap it to right there. Okay, perfect. So there's my graph. These are all of the possible solutions. Now, why did I not put arrows at the end? Yeah?
Because you can't go past, like, that's the exact number that you need, and you can't go past it.
Right. If I were to keep going into the next quadrant, I'd be getting negatives, right? I don't want negatives. That doesn't make sense in this scenario. Okay, let's take a look at the next question. It says find 3 possible solutions in the context of the problem. Here's really what I'm asking you. This is an equation that models all of the possible solutions, not just the extreme values, not just like the 30 and 0, 0, 18. This is all the possible values in between. So based on this line, let's try to figure out some possible solutions.
So like what you're saying, so could.
Where does it look like it's going to hit? That's what I'm asking.
So like could there be 20 small tables and 6 large tables?
How do we check to make sure? This is exactly what I'm asking. 20, comma 6. 20 small, 6 large. How do I check to make sure that I'm going to get 180 people? Plug it in the equation, right? This was 6x, oh, sorry, excuse me. Yeah, 6x plus 10y. So 6 times 20 plus 10 times 6. Let's see what that comes out to be. Well, I can do this in my head. This is 120 plus 60. 180. That checks out.
Jack, you know that off the top of your head.
Oh, that's just 120.
Well, I don't
That's
know
just
that.
60.
I know that's
6 times 2. 6 times 2 is 12. Plus a 0.
Okay, I have that.
So this is 20 small, 6 large. You know, maybe you want to arrange your seating area in a way to form a pattern. You know, okay, well, if I have 20 small and 6 large, does that make a pattern? You know, you can kind of design it however you want at this point. Let's find another possible solution. What do you think?
8, 12.
8, 12, right here. Well, 8, 12 is right there.
Oh, my line's off then.
Yeah, this is why I think you should use a straight edge. Because your line may kind of wiggle through some spots that shouldn't. Gio?
8, 4.
8, 4 is right there.
Well, 12, 4.
12, 4? That's right there.
What Brianna said, wouldn't that be 8, 13?
Let's check. Let's check 8, 13. Will 8, 13 work? That's 6 times 8 plus 10 times 13. Now, I don't know that off the top of my head. But let's plug that in. 6 times 8 plus 10 times 13. Will I have enough seats?
Nope.
No.
Try 14.
So that will not work. Okay, try 14. Same entry, but now 14. Now, let me ask you this, because this came up last period too, because we were trying to, fudge the numbers a little bit here too. Will that work?
I mean, yeah.
Yeah, like in this scenario, do we need to hit 180 on the dot?
No.
No, it's okay if we have extra space. We are not told about any like spatial restrictions for the amount of tables I can fit in a certain room or the orientation that I need. So in this case, I would say sure that 8, 14 would work. I don't know why I changed colors there, but 8, 14 would get us 188 seats. And yeah, I guess that will check out. So I could use 8 small, 14 large. Nathan?
Even though it's not on our line.
See, I see, and that's the thing that we came up with last period too. Even though it's not on our line, if I choose to say I want greater than or equal to 180 people, once I change it into an inequality, now we won't get to this till next chapter, it actually becomes not just a line, but actually a shaded region. And the region would be all of the solutions. And that point, 8, 14 is actually in that region, so it would work. So we're kind of jumping ahead a little bit. Yeah.
Would 26,2
26, 2 right here. Let's check it.
28, 26.
Oh, 26, 2. Let's see. 6 times 26 plus 10 times 2. Not enough. 176.
So
Yeah.
close, though.
You can see what I'm getting at here. You could keep trying points along the line. I know I told you to find 3, but what I'm getting at here is that you can find points along the line. Those are all solutions in there. You just have to keep running the numbers till you find things that work. Okay, let's jump to the next problem because I don't want to get to this one too. Ooh, we're running out of time. I got 10 minutes to do this problem, people. 10 minutes.
That's an eternity in math class.
That's right. I feel like I say that a lot of times. You're planning a birthday party and have $160 to spend on flower bouquets. You're planning a part. You got $160 to spend on flowers?
Why?
I don't know.
Why not?
All right. Okay. The florist sells 2 types of bouquets that you might want: roses and tulips. Roses and tulips. Roses naturally more expensive. They're $40 per dozen or per bouquet, and tulips are only $20 per bouquet. Now, and that's actually true. Roses are a lot more expensive than any other. Now, the equation 40x plus 20y is equal to 160. That models this situation. 40x, where x is the amount of roses, and 20y, where y is the amount of tulips, is equal to $160 altogether. Let's find the intercepts. 40x plus 20y is equal to 160. Okay, so for the sake of time right now, all I need to do is just say this. 40x is equal to 160. Because if I plug in 0 for y, isn't that going to cancel out anyway? So why not just go straight there? I divide by 40 over to the other side. I get x is equal to 4. Again, that's the beauty of standard form, is that it's quite easy like that. Just cancel out the other term. And then I can just have 20y is equal to 160. So y is 8. Yep. Okay, so that means I've got 4, 0 and 0, 8. So what's the interpretation of that intercept? 4, 0.
You can try either 4 bouquets of roses or 8 bouquets and no tulips, or no roses and 8 bouquets.
Good. Those are both the interpretations. Yeah. We can have 4 roses and 0 tulips for $160. Or the other extreme, 8 tulips and 0 roses for $160. I have seen a question every single year on the OST that asks you to interpret intercepts. Every single year. It's all about the extreme values. All of one and none of the other. All of x and none of y. Or all of y and none of x. Okay, so it looks like x is our roses. And y is our tulips. Okay, I've got 4, 0. Okay, looks like I can fit 4 pretty easily on here. Let's make this 1. 2. I'm going to go by 3s in my boxes. And for tulips, I'm going to go 8. So 1, 2, 3, 4, 5, 6. Oh, man. I got to go up by 1s? It's a bummer.
It's okay.
Thanks. Thanks for the support.
I'm already done.
1, 2, 3, 4, 5, 6, 7, 8. Okay, there we go. All right. So blue and red. Okay. Graph my line between them. Again, no arrows on this because this is a word problem. Okay, what coordinates do you think are going to be solutions? That's the last question on this, right? What coordinates do we think are going to be solutions? Give me coordinates.
All 3 or just 1?
Just 1.
3, 2.
3, 2. Let's check 3, 2. We think 3, 2 is going to be a solution. What does that come out to be? Well, again, it's 40 times 3 plus 20 times 2. 160 bucks? Yeah, that's a good combination. Okay, so 3 roses and 2 tulips. Okay, Gio? 1,6. Let's check it. Let's see if that actually comes out to be $160. 40 times 1 plus 20 times 6. $160. So this is 1 rose, but 6 tulips.
So, like, right here, there's like it looks like a point. What about, like, since it's not that kind of number, could we, like, do half the bouquet?
Then you have to think about context. Like, would the florist let you order half a bouquet? No. So then we wouldn't be able to do those values.
Okay.
Does that make sense?
Yeah.
Shh. Brennan, stop talking.
2, 4, 2 roses and 4 tulips.
Good. 2, 4. And spoiler alert, it works out. So 2 roses and 4 tulips. I didn't even have to spend all 10 minutes. Yes.
And then you do 2 roses and 2 tulips.
I didn't spend less money. See now, okay, Penny brings up a good point here. Could I do 2 roses and 2 tulips? Yeah. See, and then we kind of get into like a more inequality thing like we did last time. Could I have done like 5 roses and 5 tulips?
Yeah.
Wait.
No, I would have spent too much money. See, the other one I could have gone over and it was fine. I just needed enough room for all the people, right? I needed enough seats for all the people. I could have gone over and that was okay. This, I can't go over. I have to stay under. Okay? So it all depends on the context of the problem. But again, that's getting more into like the next chapter, the inequality, rather than the equality.
Those are so fun.
You know?
Please tell me that's
Can I? That's recorded that you just said math was fun.
Good.
I'm